All right. Thank you all for your patience. Sorry about that. For those among you who are more observant than others, I am not, in fact, John Willis. John was unable to make it here today, and as Todd mentioned during the keynote, and I quote, "For those of you who are expecting John Willis to be here, I have some sad news." He's not able to make it. And for the first half of that sentence, most people in that room thought that he was saying that something horrible had happened to John. So fortunately, that is not the case. But Todd, we love you. Please don't ever work in healthcare. I'm sorry to tell you, Mr. and Mrs. Smith, the cafeteria is out of bagels. It just doesn't go well. Okay, so let's talk instead about an impromptu last-minute talk here. Silence of the Lambdas, terrible ideas in AWS Lambda. This is more or less a survey of the whole serverless movement. And this is going to be a little on the interesting side. Quick poll here. Who uses Lambda for something today? Okay. Who has no idea what Lambda is? Okay, there are a few honest people here. Good, good, good. I don't think anyone truly knows it. The idea, historically, behind serverless has been getting away from the idea of paying a provider to run instances and running infrastructure. Instead, you just hand them some code and say, here, run this. And that idea works reasonably well. The challenge, of course, is that it, of course, is never that easy. Also, pro tip, if you ever decide to run a conference and call it serverless, be very careful about giving context to the wait staff unless you enjoy people spitting in your food. If you're presenting as, hi, we're here to take your job, doesn't play well. So the idea behind this is not just one of wouldn't it be nifty if we didn't have to think about infrastructure, but there's an economic argument for it. You're not paying for things to run by the hour. And it works better for some implementations than others. For example, the idea of small glue tasks that just need to fire every once in a while is terrific. It's picture cron jobs, but you don't have to worry about whether the cron daemon is running, or whether or not the instance it's running on is being monitored appropriately. The idea also comes down to being able to break things into discrete tasks and massively parallelize them, which is a handy way of approaching these things. It opens up the possibility of doing things in new and interesting ways for those of us who don't generally have a few thousand spare machines sitting around ready to do our work at a moment's notice. So the idea here is that you can write arbitrary code for Lambda and send it on up there in a variety of blessed approved languages that it supports. And then you wind up invoking it via some form of trigger or event source, to use their term. In other words, here's some random code, and you should run it whenever a thing happens. Whenever someone uploads an object to S3, that can serve as a trigger. Whenever a user hits a certain website or an event is received. Or even just the passing of time. It even accepts traditional cron expressions, which is super handy for those of us who never advanced past the dark days of Unix. And I am going to be talking about Lambda here because that is sort of the 800-pound gorilla in this space, but both Azure and Google Cloud have something very similar for this. For those on the more open side of the world, there are options such as OpenFaaS, which stands for Functions as a Service. This is a new enough concept that we don't have a lot of the buzzwords that have evolved around this, so we're still trying to figure out even how to define it. So before I tell you what Lambda is great for, I want to talk about things it's not great for, using some technology that I've licensed from the wildly successful startup, Hot Dog or Not. So if your code and all of its dependencies bundled together are larger than 75 megabytes, that's probably not a great candidate for a Lambda function. 75 megs is a hard limit. Now, you can get around this by, as your function starts, go ahead and grab a bunch of dependencies from elsewhere on the internet, pull it down from S3 or whatnot, but that's frankly kind of a terrible pattern. If your code requires a lot of state, databases, data stores, et cetera, or you're dealing with large quantities of data that need to be local and can't be grabbed at runtime, that's also not a great candidate for Lambda functions. The idea here is that functions run idempotently. It runs once and then it's done. And the reason behind that is in distributed systems, it is impossible, according to the tenets of computer science, to guarantee exactly once execution. You can have three real options of at most once. In other words, it will only ever run once, but it's not guaranteed to run. At least once, in which case you could have it run a second time, depending on failure mode. And who the hell even knows, which is generally how most of us tend to write things if we're lazy, and hi, I am. Also, if you want a systems architecture that a freaking human being has a hope in hell of understanding, then you absolutely don't want to use Lambda functions because it very quickly turns into a living nightmare of a sprawl. Picture microservices diagrams or a Boston street map, and you're pretty close. So let's instead talk about when we do want to use Lambda functions. So we're going to start with what a Lambda function looks like in less abstract terms and more once we start delving into these things. Because under the hood, Lambda runtimes are frankly just containers that have some somewhat interesting characteristics as a result. You don't generally get to see most of this stuff under the hood, but I have some sneaky tricks to tease information about the Lambda runtime out of it. So for starters, you can configure the amount of RAM that a Lambda function runs with, ranging at the low end from 128 megabytes all the way on up to 1.5 gigabytes. And as you scale, that winds up costing changes the amount of money that it costs. The billing metric is the amount of RAM and per 100 milliseconds that the function runs for. So this usually winds up being stupendously inexpensive. To give you a ballpark on this, if you have a function set to use 1 gigabyte of RAM and it runs for 10,000 seconds, that's going to cost you a penny a month. As a result, millions of requests pass through Lambda generally wind up costing you tens of dollars. So the economics of this as it scales generally tends to be extremely reasonable. And the CPU and network ability that a Lambda function has available to it scale linearly with the amount of RAM you allocate for it. So give it more RAM, you'll find that the CPU performance improves too. You can insert some hand waving here because there's no guarantee around how this works. It's just we know it gets faster when we start playing with it. There's also a hard limit of 300 seconds that a function will execute for. At the end of that 300 seconds, it will stop. This is a fantastic way that they've managed to solve the halting problem. How do you know that the function's going to won't run forever? Oh, after 300 seconds, it's done. And this is fun. If you run a function a second time, it may, but is not guaranteed, to reuse the container that it just used. So if you've still got an active DB connection, it'll reuse it if your code is written to take advantage of it. By the way, surprise, you get to write code that assumes that magically has to know this stuff and do all these tests. It's wonderful because it's non-deterministic whether this will work or not. You also wind up with 0.5 gigabyte of scratch space in /temp. The entire rest of the file system is read-only, which invariably surprises the living hell out of us the first time that we wind up trying to use this and write something to the file system and the function fails. And I do want to apologize. As you might tell, I'm not much of a graphic designer here. Let's add some color and maybe a better font on that and maybe a background image. There we go. Here in 2013, this is a very forward-looking talk. And so we know a lot of these things are true because Amazon has told us that they're true. But some of it that we learned from people like Eric Hammond and other people who built functions that copy things out of the Lambda environment, and then we can inspect them once they're here. In fact, there are Docker containers that emulate the Lambda environment that are built through this exact approach. There's a Lambda function that's only purpose is to scrape the entire file system and throw it somewhere else that's going to survive after the function terminates. And Clay Smith of New Relic wrote a Lambda function that opens a reverse SSH tunnel into the Lambda environment. So you now have an SSH shell into the execution environment until the function terminates. Don't do that. And if you're still unclear on Lambda functions, and want to learn more about it, there is a developer guide that Amazon makes available. If you pull it up on their website, you can flip to the Getting Started section. You'll find it on page 174. What's on the first 173 pages? Oh, it's just the foundational knowledge, because, well, actually, Lambda is very simple. And it's probably your fault if you don't understand it. So, not that this is complex or anything, but there are entire companies and open source projects that are built around nothing other than making Lambda functions and other serverless implementations easier to work with. I'm probably missing a few that have launched in the last 20 minutes since I last looked at this slide. For example, there's an AWS project just hit 1.0 called Chalice that does the exact same thing. Yes, an open source project written by AWS to make working with Lambdas marginally less terrible. Everything is awful. Welcome to technology. And the idea behind these is that they take a lot of the manual work out of building this sort of thing in a reasonable context, and you just click button, receive function. So originally, I sat down to write a bunch of demos that highlighted a bunch of terrible things you could do with Lambda. And I had some wonderful, terrible, awful ideas that I thought would be funny. For example, one of the triggers that you can use to invoke a Lambda function is you fire off a trigger by having an object appear in an S3 bucket. It then appears, the Lambda runs, it does some sort of massaging, and then it can, for example, write an S3 object somewhere else. Or not somewhere else. You could write it back to the same place, and then you've built yourself a Lambda infinite loop. And yes, this works. Well, it doesn't work. I mean, it runs forever exactly like you'd think it would, and it's broken, but it works as far as it won't stop you from doing this. Another idea I had was you can have a bunch of these things working concurrently, so why not have 10,000 of them all talk to the same database server at once? Because what could possibly go wrong? Seems like a good plan. Turns out databases don't like this. Why does it smell like metal? And of course, the ever-popular idea of transpiling through a bunch of different Lambda functions, Lambda function to Lambda function to Lambda function to Lambda function. And yes, incidentally, you can use bash for this, and you can upload compiled binaries to get the Go pieces working. And the way that that winds up working is you effectively have something that's written in code as more or less a one-liner that shells out or invokes the thing you just uploaded. And yeah, Lambda functions can call other Lambda functions. It's like a game of telephone with the express purpose of making us hate our lives. And my personal favorite, demonstrating large-scale projects that can be done with piecework. So a fun fact is that for a long time, the Elasticsearch default password was change me. And I can test for this programmatically. Completely unrelated fact. There are 4.2 billion IP addresses on the internet. I can test for this with a calculator. And when you combine these two facts, you learn that I probably should have started writing a talk sooner. So, little math on this. It's going to be a bit over $9,000 to run this, incidentally, if you wind up firing this off. But that's why you use someone else's AWS account for this, as opposed to your own. Suddenly, it's a lot less expensive to you personally, and that's what it's all about. That 1,000 at a time, incidentally, is not just an arbitrary number. By default, in a new AWS account, that is the number of functions you're allowed to run concurrently. This is more or less a safety mechanism to keep you from doing something truly horrific. If you ask them nicely, they will raise that for you. So I did. I didn't have time to wait for since I waited to the last minute, I didn't have 46 days sitting around waiting for my ridiculous, expensive project to complete. So yeah, can you please set my account to run 4 billion concurrent Lambda functions because I want to scan the entire IPv4 internet for vulnerable Elasticsearch clusters at the same time? And the reason is I think it would be funny. And as it turns out, Amazon has 13 leadership principles that they hire people based upon, and one that isn't mentioned in those at all is a sense of humor. So you can probably guess how that conversation went out. And now there's a shoot-to-kill order on me if I ever enter Seattle again. And I originally thought all this stuff was funny. And it turns out I was wrong. Because it wasn't funny. It was actively hilarious. But more than AWS being spoil sports about letting me turn their flagship serverless offering into an attack platform to actively make the internet a worse place to be, I had a bigger problem. Namely that a lot of people out there are using Lambda for fascinating, interesting things, and they looked at my ideas for this talk and said, "You're adorable, child. Here, hold this for a minute. I'm going to need that back." So the fundamental problem here was that I wound up getting upstaged by things that people wrote, put into production, and signed their name to. And what I found made all of the ridiculous ideas I mentioned previously look like contrived nonsense. So, haha, this is funny, sort of pales in comparison next to we did this and open sourced it, apparently with a straight face. So as a result, this is now a talk about Lambda versatility, because I can't, in good conscience, get up on stage and make fun of people's hard work directly. So now I'm casting this as various proofs of concept that people have done with Lambda. Does anyone know what this is? Don't be shy, shout them out. Sort of. Usually it's wrapped in that. Yeah, Commodore 64. That is a 6502 processor. And given the context of the talk I'm bringing this up in, you probably know what's coming. That's right, someone built it. You now have Lambda functions that can speak in 6502 assembler. Compared to that, building a Lambda that invokes itself doesn't really compare. It's the 1980s are back again in the cloud. It's amazing. Oh yeah, it's a great learning platform. It's just not, shall we say, a modern best practice in most shops. Except there's one place I worked at, and I still have the scars from that. Perhaps other folks have heard of ClamAV, the open source virus scanner that analyzes files to make sure that they're safe. Perhaps some of you run it. Perhaps some of you should get back to 2013 where this stuff belongs, because we're talking about serverless now. Airbnb wrote something called Binary Alert that serves the same function. The idea is that you get a binary into this thing, it has a bunch of rules, scans the crap out of it, and then returns whether this is a malicious binary or not. Instead of yum install ClamAV like I'm some sort of ancient caribou trekking across the tundra somewhere, now we can go serverless and web scale. And yes, this is an actual diagram from their documentation of how it works. So why have a simple tool when you can have 3 Lambda functions, S3, the simple queuing service, CloudWatch, the simple notification service, DynamoDB, and a few more thrown in for fun? Because at this way, you don't have to run servers anymore, so things are great. And oh, by the way, just like with ClamAV, getting the file into the system in the first place is also left as an exercise for the reader. This is just a helpful reminder that when people build stuff like this, it's pointing out the #1 project that they're working on is their resume. So this one's fun. Don't be fooled. This is George Porter. He's an assistant professor at the UCSD Computer Science Department, and he is, of course, not a Lambda function. I have another Lambda function here that told me so. It's, training that stuff on neural networks is awesome. So he wound up building a thing. It turns out that John Emmons is a PhD student at Stanford. And he, in conjunction with the previous gentleman, wrote AWS Lambda Face, both as a proof of concept as well as a neat toy to play with. And earlier this year, John went to NSDI in Boston, which is a Usenix conference that focuses on distributed systems. And he went there, as one does, and he spent the day at the conference with a GoPro strapped to his head, as one most assuredly does not, or at least shouldn't. And what's fun about that, by the way, is in the background you can see the Facebook sponsor banner, and they're looking at him with a GoPro strapped to his head, probably going, amateur, we'll show you how surveillance is done. I digress. So at the end of this conference, he has over 6 hours of video from this thing. And because of this talk, you know where this is going from here. He fired it off into a series of Lambda functions to analyze each frame individually to see if it has George in it. He then wound up stitching those frames back together into a video montage, and we learned a few things. We learned that in 6 hours, George is willing to spend 17 seconds talking to someone at a conference with a GoPro strapped to their head. The point being is that when you have projects that are massively parallelizable, Lambda is an awesome and efficient tool for this stuff. To break that video down from 6 hours to 17 seconds cost $8. That includes, incidentally, the time of an EC2 instance that was managing these things as well, because at some point you can't go purely serverless. You have to admit you have to have some sort of master controller that works. The more interesting statistic is that it took less than 5 minutes to consume that entire 6-hour video. Of course, not including the time it takes to upload that, but assuming that he wasn't on conference Wi-Fi at the time. At certain points of scale, Lambda becomes an awesome and efficient tool. Incidentally, Lambda is also certified to pass PCI. You can work with HIPAA with it, so you can put, yes, people's private healthcare information through it, and that's kind of awesome and terrifying. But in 2015, when AWS announced that Lambda was now available for general use, their headline was that Lambda is now generally available. That's also their SLA. So do you guarantee 3 nines? No, but it's generally available, except the times when it isn't. And that becomes a little bit of a problem. Lastly, I want to talk a little bit about using Lambda to make people regret ever letting me near a computer in the first place, let alone theirs. I'm going to start with a disclaimer here. This is really more for humor than something you should actually do, despite the fact I have a surprisingly workable code sample coming up. Please don't do this. Please don't hate me. Please don't sue me. Okay, we mentioned earlier that virtually anything can be a Lambda trigger. And AWS gives examples of this in demos all the time. You have an example of a warning when you hit certain spending thresholds, budget alarms. You can use it to clean up the remnants of auto-scaling groups that have since terminated. You don't want all the cruft that's there as a result. And obviously, because they're trying to sell us things, most of their examples include using the AWS APIs themselves as a target for what the function can do. Reasonable. On a completely unrelated note, did you know the AWS support system has an API? And you can use it to do things like open support cases, maybe with a parameter like the error message that you're just getting. So theoretically, every time you encounter an error thrown by an Amazon API, you could automatically open a support ticket. In fact, your try-catch blocks could open thousands of high-priority support tickets an hour. And when the support API itself starts throwing errors, well, you can open a ticket for that. You ever wonder why Amazon support is sometimes slow to respond? Yeah, that's me. Sorry. Forget the boy who cried wolf. I'm apparently the boy who breeds them. I am going to, incidentally, here's a link for those who care. I'm about to have a bibliography of links, and I don't want people to have to frantically copy those down. All of my slides for this presentation live there. So if you want to go ahead and grab them, feel free. I will tweet it out after as well. And everything that I have mentioned here so far, I do have a link to, rather than just, you don't have to take me at my word for this. I brought this up with documentation. So thank you all for listening to me talk. Does anyone have any questions about Lambda in general, serverless, why I'm a poor imitation at best of John Willis? We also accept what's the matter with you as a valid question.
I have that question.
Yeah, so do a lot of people, it turns out. Yeah. Perfect. I also want to thank Randall Hunt, who's a senior technical evangelist at AWS, or so we thought, but when I was building this, I accidentally put that picture in the wrong place. Turns out he's 30 Lambda functions wearing a hoodie. In fact, if you DM him on Twitter, more often than not, a Lambda function responds. That's a terrible idea. This has been Silence of the Lambdas. My name is Corey Quinn. I hope you've enjoyed this, and please enjoy the rest of the day.